Hello all. So welcome to the second video on Julia programming language. In this video mainly I discuss about the various number data types supported by the Julia programming language. Particularly in this video I discuss about the four number data types: integers, floating point numbers, complex numbers and rational numbers. My name is Kishor. Welcome to the KASHE channel. Let's start the topic now. Numbers in Julia. Here this particular tree shows that all the number data types are supported by the Julia. Now I discuss these types with some examples in simple way. First we will consider the integers. So integers are the whole numbers. Those can be positive numbers, negative numbers or zeros. Here the default integer type depends on the system architecture. If your system is a 32-bit system, then the default integer type is int32. If the system is 64-bit system, then the default integer type is 64-bit integer, that is int64. Now I am considering a variable num1, then I am assigning a number 89 to it, where 89 is a positive whole number. Then I am displaying the variable num1 with the help of println function. Println is a function we have with Julia to display a text on the monitor, which will append a new line character at the end of that text. Then if I run this cell, then 89 is displayed, which is the value present in num1 variable. To display the type of any variable, the Julia is having a function type of. Here I am using the type of function with num1 as an argument. If I run this cell, then the type is int64. If I use sys.word_size, then we will get the word size of the system. Here my system is 64-bit system, that's why the default integer type is int64. Now I am taking num2 as variable, then I am going to assign a negative number, negative 92 into that. Then I am displaying the value present in that num2 variable and also the type of that num2 variable. If I run this cell, then I got the value present in that num2 variable as negative 92 and which is of int64 type. Now I am introducing another two built-in functions with Julia, type min and type max. Type min is a function which returns the minimum value that a particular data type can hold, and the type max returns the maximum value that a particular data type can have. Then I am going to display the minimum value and the maximum value that num1 variable can have. Here type min of num1 and type max of num1 I am using. If I run this cell, and this is the minimum value that 64-bit integer can represent, and this is the maximum value that int64 can represent. Julia is having the number of functions to convert numbers from one type to another type. Now I am going to convert the num1 variable, which is of type int64, to 8-bit unsigned integer. For that we have function uint8. Here I am using num3 as a variable to hold that unsigned 8-bit integer after the conversion. Here I am converting the number 1 to 8-bit unsigned integer. Now I am going to display the value present in that num3 variable as well as the type of that num3 variable. Then we got 89, that is the same value we have in num1 variable in num3 variable as well. And then if you observe the type of num3, which is of uint8, that is 8-bit unsigned integer. Then I am going to display the minimum value that num3 can have and the maximum value that num3 can have. Here I am using type min and type max functions with num3 variable. Now I am running this cell again. Then I got 0 as the minimum value that 8-bit unsigned integer can have, where 255 is the maximum value that unsigned 8-bit integer can represent. Guys, so far we have considered decimal number system to represent integers. We can also use other number systems to represent integers here. Now I am going to take integer value in hexadecimal number system, octal number system as well as binary number system. Then I am going to display the equivalent value of a hexadecimal number. So hexadecimal numbers can be represented by starting that number with 0 and x. Now the hexadecimal number here is a. If I run this cell, equivalent decimal value is 10. Now that 10 is integer now. In the same way, I am going to represent integer by using octal number system. To represent an octal number, we have to start that number with 0, O, and then I am using 1, 2 as the octal number, which is equivalent to the 10 decimal number. If I run this cell, again I got 10, which is also integer now. And then I am going to represent a decimal number by using binary number system. Then I am using 1010 as the binary number. If I run this cell, again I got 10 because 1010 binary number is equivalent to 10 decimal number. So this is also integer now. So that's all about the integers. Now I am considering next type of numbers, floating point numbers. Floating point numbers are the numbers which contains decimal point. We can represent the floating point number by using the standard form using the decimal point, or you can represent the floating point numbers by using the scientific notation using a letter E. Then I am taking a variable f1. Then I am assigning a value 13.7. Then I am going to display the value present in that variable f1 and the type of that f1. Then 13.7 is the value present in that f1 variable, and the type of that f1 variable is 64-bit floating point number. Because my system is 64-bit system, by default that floating point number is 64-bit floating point number. I am taking a variable f2. Then I am assigning a value minus 1.0. Then I am going to display the value of f2 and the type of it. Now we got value as negative 1.0 and which is of type float 64. Now I am going to represent the floating point number by using the scientific notation. For that I am taking a variable f3. Then I am using 2e2 as the value into f3. And this number is equivalent to 2 into 10 power 2. Then automatically f3 value becomes 200. Now we will display that. Then we got 200.0 as the value present in that f3 variable. Then I am going to display the type of f3 variable. Then we got float 64 as the type of this f3 variable. So if you want to specify a 32-bit floating point number, then we can use a letter F in the scientific notation instead of a letter E. Then if I consider an example, a variable f4, then I am assigning a value 23f minus 2. So that is equivalent to 23 into 10 power minus 2. Then I am going to display the value present in that f4 as well as type of f4. 0.23 is the value present in that f4, which is nothing but 23 into 10 power minus 2, and then its type is float 32. Then Python is also having a built-in function float 32 to convert a 64-bit floating point number to a 32-bit floating point number. Then I am taking a variable f64. I am assigning a value 1.0 to that. Then I am displaying the type of that variable. Then we got float 64. Then I am converting 64-bit floating value into 32-bit floating point value. Then I am taking a variable f32. Then I am using a function float 32. Then as input argument I am using f64, and then I am going to display the type of f32. Then we got float 32. Here the use of this conversion is to save the space. And the next thing is use of underscore as digit separator. Julia allows to use underscore to separate the digits. I am taking a variable val. Then I am assigning the value 1 underscore 000, obviously which is equal to 1000. Then I am going to display the value present in that val variable. Then we got 1000. So next type of numbers would be complex numbers. You know what is complex number? If any number is having both real part as well as imaginary part, that means if the number is available in the form of a plus ib, then that particular type of numbers are called as complex numbers. In Julia, the imaginary part is represented by using im. That means if you want to represent a complex number a plus ib, then we have to represent that number as a plus bim in Julia. We know that im is equal to square root of negative 1. That means im square is equal to negative 1. Then I am considering an example here. I am taking a variable c1. Then I am assigning a value 2 plus 4im. Then I am displaying that c1 and the type of that c1. Here 2 plus 4im is the value present in c1, which is of a complex type, where the real and imaginary parts are of type 64-bit integers. Now I am considering another example. C2 is a variable now. Then I am using minus 2.9 plus 4 im as the value. Then I am going to display C2 and its type. Then we got minus 2.9 plus 4 im is the complex number present in C2. If you observe here, as imaginary part I have used an integer, but since the real part is a floating point number, then the imaginary part is also converted as floating point number, that is 4.0 we got here, where the type of this particular C2 is now complex number, where real and imaginary parts are 64-bit floating point numbers. Then I am going to consider two functions in Julia, real and image, and the real function returns the real part of a complex number and image function returns the imaginary part of a complex number. Here 2 plus 3 im is the complex number I am considering, and then I am using that complex number as input argument for this real function. If I display the value returned by that real function, I got 2, which is the real part of 2 plus 3 im. In the same way I am going to use imag function, then which returns the imaginary part of that complex number, that is 3 in our case. So next I am considering the rational number supported by the Julia, and then you can represent a rational number in Julia by using double forward slash as an operator. After that we can use a function numerator to extract the numerator value, that is p, and then we can use a denominator function to extract denominator value, that is q. After having said this, I am going to consider some example. I am considering a variable r1, then the rational number I am considering as 4 double forward slash 5, where the value p is 4 and q is 5. Then if I display the value present in that r1, we will get 4 2 forward slashes 5, that is 4 by 5 rational number. Then I am going to display the type of that r1. Then we will get a rational as type, where p and q values are 64-bit integers. Then I am going to use a numerator function to extract the numerator and a denominator function to extract the denominator. Then 4 is the numerator and 5 is the denominator. And finally I am going to consider a function float, which can be used to convert a rational number into a floating point number. Then I am taking another variable r2. I am assigning a rational number 55 double forward slash 89. Then I am converting that number into a floating point number with the help of float function. Then if I display the value present in that r2 as well as fval, we will get 55 by 89, which is the rational number present in r2. After converting that into a floating point number, we got 0.6179 as the value present in that fval. Guys, that's all for today's video. This information is more than enough to start the next concepts. I will meet you with a new concept in the next video.